let's move to our next topic, that is simple pendulum. Now how simple pendulum works, what is the motion of simple pendulum, we are going to understand in this slide. Now here in the image you can clearly see that first of all the simple pendulum involves the rigid support on which the pendulum is hanged or swing. After that it is attached with a thread, and at down a bob is there which moves, which is like a ball. It is of metal and it completes or do the motion which is oscillatory motion. Now here clearly understand how the motion of simple pendulum is made, or how the simple pendulum do the movement from its one position to the another, and how that positions, what are the names of that position, that we are going to understand now. Now here see that first of all, as I've already said, that it has a rigid support on which it is hanged, right? Like in watches we have seen that at the down of the watches, like here watch is there, at down the watch pendulum is hanged like this. Now that and it do this motion, like it moves this side, that again come back to this position, again move to this side, and again come back to its normal position. Now we'll understand this motion clearly here. Now first of all, as I said, it has a rigid support on which it is hung. After that it has a long thread like that from which the metal bob is hanged, or we can say that attached, which is a long thread, and down here is a metal bob which basically do the motion, right? Now how this motion is done, now the position when the pendulum is at rest like this, we can say that this position, this one is a mean position, and when it moves to this side like this, if I say that this one and this one, so these are the different position. If I give name to this like A, B, C. Now A here is a mean position, while B and C are the extreme positions. So that is how the pendulum moves, or we can say that this is the motion of pendulum. So as I have already said that A is the mean position and B and C are the extreme position. And this is how the pendulum do the motion. Now in the pendulum, what is the most important thing is the bob, which is at present at the downward, that is ball-like structure. It is suspended freely so that it can move back and forth easily. Now when it is doing this motion, to and fro motion, this to and fro motion is known as oscillatory motion. This you have studied in your last class also. That is when the motion is back or forth, or when an object is moving from its mean position to its extreme positions and again coming back to its mean position, then it is known as oscillatory motion. Now, and the one round from mean to extreme and then again to mean and coming back to its original position is known as one oscillation. Now here clearly see that and understand what is one oscillation and how we count one oscillation. Like I've already said that this is a rigid support on which the bob or on which the pendulum is attached, and after that we have a long thread on which the our bob is attached, and down we have the bob. Now this is our A position, which is known as mean position. Again, when the pendulum moves from its mean position to one of its extreme position, like here, like this, and again come back to mean position, and from here we'll give this to name as B. This is our extreme position. Again, what it will do, it will come back to its mean position, and from here it will again move to another extreme position, and let's give this a name as C, and again it will come to its mean position. Now this whole round is known as one oscillation or counted as one. So that is our one oscillation. That is when the bob is moving from A to B, coming back from B to A, and then moving from there to C and coming back to A. So that is how one oscillation is counted, right? Now every oscillation of a pendulum is always take exactly the same time, provided that its length is constant. So what this line means is that the length or the oscillation completed by each pendulum, in that case the time always remains the same. That is, a pendulum, if a pendulum is of like 3 cm of length, the thread is of 3 cm of length, the time taken by it is 1 second. Now that pendulum will cover all the oscillation, like for each oscillation it will take 1 second itself. That means the time will always remain same, time won't vary. All the pendulums have their different time. Now the oscillation which is covered by the pendulum in some time, that is known as time period. That is the time taken by the pendulum to complete one oscillation. We have already discussed what is one oscillation. That is when the bob, or we can say the pendulum, moves from its mean position to its extreme position, again come back to its mean position and moves to another extreme position and again come back to its mean position. So that is our one oscillation. Now the time taken by the pendulum to complete that one oscillation is known as time period. Now this time period basically depends on the length of the pendulum, like the length of the thread of the pendulum on which the metal bob is attached. Because of that, the time period varies. If the length is larger, then the time taken by the pendulum to complete one oscillation will be more, and if the time taken is less, then that means the length is also small. So that is how the time period depends on the length of the pendulum.